Welcome, everyone. Guess we're just going to go ahead and get started. I apologize for the projector. Normally you can read that. But we are talking about account abstraction today. My name is James Bork. I'm a San Francisco native who decided to move to Europe, so I'm based in Paris now. Co-founder and co-CEO of Intu. Intu, we do multi-party computation threshold signatures in an SDK. So the conversation today is really to get a good understanding of account abstraction, 4337, all the cool things that we've been talking about since Denver, but also kind of look at more holistically what the good is, what the kind of shortcomings are that most people aren't talking about yet, and getting a better understanding of how to really fix UX for this next billion users that we keep talking about, right? So I think everyone in the room can agree that like private keys are scary. Every time I get on an airplane, I open the safe, I look at my ledger and I say, are you coming today or am I leaving you behind? Will I need you? And it's scary because if you lose it, you lose everything, right? There's no way to recover, but that's also the beauty of Web3 is that I can create an identity for this network that I own completely, that no one can take from me. It is self-sovereign and it is mine. So, generally speaking, I'm assuming we have a wide variety of kind of expertise levels. Accounts in Web3, there's two basic types. So we've got, the first one is smart contract addresses, right? So these have no private key. These are basically applications that live on the network, and they don't need to identify themselves to the network because they're in the network. For the rest of us, we have what we call externally owned accounts. This is your public address with your private key. We use our private key to be able to verify to the network that we are the actual owner of this account, of this address. So the beauty is, like I said before, they're self-sovereign. You control it, you create it. And this allows you to form messages and transactions, which is how we interact with blockchains. But at the end of the day, EOAs just don't meet human expectations, right? We make mistakes, we lose things, we misplace things, we forget our cell phones behind. Single key means single point of failure. No form of account recovery means that if you lose that seed phrase in addition to your private key, you lose your computer, whatever, it's gone. Most of this, right, it's one size fits all. It was great for the beginning, but we kind of have to grow. And frankly, I think we all agree that, oh, it's not the system's fault. The system worked exactly as it was supposed to. This is human error. That's a really bad response. It's like building a tool. If you keep cutting your hand off, you probably should build a better tool, right? The last thing that we don't talk about enough is the fact that private keys are static. In Web 2, right, every CISO on earth will tell you that you should refresh your credentials. Your bank will ask you to reset your password every 3 months because the longer a private key has been in use, the more likely it has been compromised. In Web3, you don't have the ability to change your password. You don't have the ability to reissue credentials. If you need to protect yourself, you have to transfer every digital asset on every single network from one account to the other. And that's just not realistic. So here comes account abstraction, right? Which is just another crazy way. So this says account abstraction equals human expectation. They give us better usability, they give us more functionality. They do this by creating distance between the private key and the account itself. So for the most part, right, account abstraction, the whole goal is to create accounts for end users that more closely approach human expectations, right? I should be able to lose my password and reset it. I should be able to not have gas and still do things on the network. The way that we're solving this right now is by using smart contracts. So when you hear the word account abstraction, what you're actually hearing is smart contract accounts for human beings. 4337, right, that the Ethereum Foundation announced back in March, it's not actually new. Like, we've been doing this for 5 years. What 4337 has done is it has provided a standard language for developers and builders to talk about what we're trying to achieve, right? As an example, proxy payments, right? Like being able to subsidize a brand new user without requiring them to have gas. That's the gas station network. That's been around for 3 years. Biconomy has a proxy payment platform where you can basically stream money and pay for new users and then get refunded however you like. Things like social recovery. That was Argent's unique selling point, 4 years ago, 5 years ago. Distributed ownership, that's Gnosis safe. That's a multi-sig. So these are all old things that just 4337 has, one, defined a common language for things to be more interoperable. Two, there's this really awesome community behind it. So now we have a narrative, we have a story, right? We can now talk about account abstraction holistically as a goal of pushing, right, these better human experiences. And then the last thing, and this is really the innovation from 4337, is infrastructure, right? So they introduced a higher level meme pool called, they're called bundlers. And so these 4337 transactions don't go directly to the consensus layer. The reason they were able to do it 4 months early is because they did it a layer up, right? And so we have a little bit of new infrastructure, and there we go. The bad part, the part that we don't talk enough about, right? Everyone's so hyped on account abstraction right now. We keep talking about the positives, the future. Look at all the cool things that we can do. These are important things, though, that we have to address. So the first one is the fact that currently most dApps don't support smart contract accounts. And this is very intentional because smart contracts are programs. You don't want bots slamming your protocol. So you don't receive transactions and messages from smart contract accounts. Most of them are only supporting EOAs. Cross-chain compatibility, right? One thing that we take for granted in Web3 is that you create one address in your MetaMask, and you can use that same private key and public address on Polygon, on Avalanche, on Phantom, on Optimism. You don't have to think about what you're signing with. You just go to a little drop-down and you change the network. I know for most of us, we've been saying, oh, this is really annoying, this is a horrible user experience, whatever. But the alternative is cross-chain address front running, right? I launched this smart contract account on Ethereum. If I don't launch it on Polygon, someone else can have that address ahead of me. And now instead of managing one private key, I have an alphabet soup of addresses for every different network. And as new networks pop up, right, you have to immediately launch on that. Good case in point for this, I don't know if you guys remember the Wintermute hack from a few years ago. They were transferring, right, to Optimism. Someone front ran the Gnosis safe on the other network and intercepted I think it was like $100 million or something, right? So this is a problem that we're not talking about and that we're thinking about solving, but it's something that we need to kind of more holistically approach. The third, obviously, is introducing developer risk, right? Smart contracts are tricky. Anyone that's tried to deploy a Gnosis safe knows that the docs make it sound super, super simple, but the minute you start trying to do streaming payments, batch transfers, different kinds of account recovery, that those modules get really, really complicated. And if you don't configure those modules correctly, they actually have more authority over the smart contract account than the individual users themselves. You can call the module directly and drain an entire smart contract account. And that's because that's what's required from the flexibility of setting up a Gnosis safe the way that you want, right? So there's a lot of new developer risk. And then the last one is what we're calling arbitrary user verification. Yay. We are now putting it in the hands of developers to determine how external users, human beings, you and I, identify ourselves to the network. So if we're using BLS, fantastic, cryptography is great. But if we're using Twitter, we just spent years developing a decentralized network to get away from these centralized services, from these centralized companies that are being our identity providers for these networks. If we go back to just doing single sign-on, just using Twitter, just using socials, just using your cell phone, we're kind of in the place that we started. And now we've just made a very expensive Web 2, right? I'm not really sure why. So this is a narrative that we have to push as a community. We have to keep an eye out for these things, but it's not all doom and gloom because we have kind of the newer tech that's coming out, right? The next generation stuff. So at Intu, we're calling this distributed externally owned accounts. This is a static public address, but no more private key. And so we are using multi-party computation and verified secret sharing. We are not the only MPC provider out there, right? You've heard of Fireblocks, you've heard of BitGo, you've heard of, BitGo, Zengo, Lit Protocol, right? There's a lot of us. The result is you still have your static public address, but instead of having a private key, you have key shares, right? And these key shares, depending on the network, depending on the solution, have different degrees of variability. They are dynamic. You can lose them, refresh them, change them, right? It's a dynamic private key. And then you go ahead and use threshold signatures to go ahead and sign for that address. I'm not going to get super into the weeds on the cryptography. If that's something that you enjoy, we're at the table. Come by. We can talk about ZKPs and how they factor into MPC, threshold signature stuff all day long. But the end result is that it's still an externally owned account, right? It behaves like an externally owned account. So everything on the network still works the same way that it does. So you have broad compatibility, you have a lot of flexibility as far as treating ownership and custody, and the interoperability between dApps that we've come to expect. So today I learned, what is MPC? It's the next generation of accounts for Web3. Like right now, we're kind of at this weird inflection point where we're trying to stream video, but we're still using dial-up, right? So we can come up with all the crazy, cool compression algorithms that we want, right? MPEG-2, whatever. Like Real Player still isn't going to stream as well as YouTube does on broadband, right? YouTube had its moment because broadband became available. We need to make sure that our accounts are using this next generation technology. We don't want 56K dial-up streaming, we want fiber. The great thing about multi-party computation, it preserves the cryptography. Cryptography is essential to what makes Web3, right? We are crypto networks. We don't want to throw the baby out with the bathwater. So by making everything programmatic, we're also losing the safety and the security of the math that enforces the principles of Web3. So the way MPC works, basically one person proposes that we create this new account. We share secrets, but only parts of secrets. Once we all have secrets, we combine the secrets and voila, we have an account. And as long as I was part of that process, I will always have a key share. And then whatever the threshold is that we determined, you can go ahead and use that to basically enforce basic governance, right? You can say, I need 3 out of 5 to form a signature for a transaction, but we need 2 out of 5 for account recovery, because if we lose 3 people, then we're in trouble, whatever. And because it's all cryptographic, it's immediately available on all the EVM compatible chains. And frankly, because it's ECDSA, it's really any ECDSA based chain for now. So this is, again, just another illustration of kind of how this works, right? So you have flexible ownership, you have broad compatibility. So now as an individual, I can have one static account, I can have my one identity, and I can distribute the risk of that ownership between my mobile, my desktop, my ledger, my paper wallet. I can give it to someone that I trust. If we're an organization, it could be our board of directors. So if the CEO goes Quadriga CX on you, it's okay, right? You don't have to worry about that. And you just decide, designate your percentage of shares to go ahead and form these signatures. At the end of the day, really, kind of the point that I'm trying to make is that multi-party computation and account abstraction together, that's the match made in heaven, right? Like, it's going to be a weird dating process, but once we get through it, like, this is going to be great for our end users. This is what's going to enable the next billion people to join Web3, is these two working together. The narrative right now is trying to propose one solution or the other as a silver bullet, and I'm here to tell you that it's not, right? Together we can have the safety, the security, the reliability, the compatibility of cryptography, but then use account abstraction to create custom experiences for different applications, right? Like, we have different types of cars because we have different kinds of needs. If you're living in San Francisco, you probably don't want to be driving a double wide pickup truck, right? But if you're living in Texas, you probably don't want a Mini Cooper, right? We need to be able to use account abstraction to designate those kinds of experiences. This is a Web3 game. I need streaming payments for my Web3 game so that my end user isn't doing microtransactions every time they try and get a loot box. But if you're doing DeFi, you don't need streaming payments. You need low latency. You need it to be fast, right? You need to be able to be reactive and form signatures in a quick and reliable way. The good, it's a great first step. I'm glad that we now have a common language to start approaching some of these issues. We can start using 4337's definitions to collectively build a better user experience. But we need to make sure that we include the cryptography bit, and that we also establish maybe not standards, but best practices around how we identify external users to the network. while also making the kind of the beautiful parts of 4337, the proxy payments, the streaming payments, the privacy preservation, being able to like resolve and verify BLS signatures on an EVM chain without a consensus layer change, right? Like these are huge. Without requiring 100% trust in smart contracts, without having to worry about people upgrading the smart contract account that's dictating your identity on this network without your authority, right? Without having to worry about the unforeseen impacts of arbitrary verification, giving the power back to the Googles, the Twitters, the Apples, and making sure that normal users don't have to maintain an address book of every single smart contract address that they have on every single network. And then also trying to remember how they verified to it. So on mainnet, I'm using my biometric, but on Phantom, for whatever reason, I'm using Twitter. Right now it's like you're logging back in, you're like, which email did I use? Which password did I use? Did I use this one? Did I reset it? Like what happened? We don't want that. We need to do better. One thing that's very promising that 4337 is discussing and that we're also looking at in the MPC community is the use of WebAuthn, right? So tying into like the FIDO2 standards so that we can support biometrics, we can support single sign-on, but taking these user-friendly ways of identifying yourself and turning that into cryptography that we can then use on Web3. I mean, unfortunately, the curve that WebAuthn uses is very, very close, but not the same, right? SEPIC 256K R1 versus K1, right? One letter makes all the difference in the world. But here we are, we have people that are building bridges. So like Zengo has done an excellent job of enabling biometrics on their retail-facing wallet using MPC. Fantastic. Now, if Zengo also partnered with account abstraction, we'd have basically what we're looking at, right? That's kind of what we want. Anyways, guys, thank you so much. James Bork from Intu. If you guys want to keep this conversation going, here's my Telegram, here's our Twitter, and we'll be around all day. So really appreciate it. Thanks, guys.